here it has given example of few relation uh, in the Pine Valley Furniture Company. A customer relation, it has customer ID attribute as primary key, customer name, address, city, state, postal code, then an order a relation by the name order having three attributes: order ID, order date. Actually it has two attributes, and this one is the foreign key. So actually this attribute was added to create a relationship between customer and orders. So customer ID is a foreign key here. Order line, now see, this is how you represent a composite key. Order ID and product ID, these two fields combined becomes a primary key. So a primary key that has more than one attribute in it is actually called a composite key. So here order ID and product ID is a composite key, and the other field is ordered quantity. And then the last relation is product. It has its primary key is product ID, and then it has these field: description, product finished, and price, and product line ID. So this is how you present a composite key. These are the same relation represented in a diagram form. Okay, now we come to the integrity constraints. There are three types of integrity constraints: domain constraints, entity integrity constraints, and referential integrity constraints. So let's start with domain constraint. Domain, what is a domain? Domain of an attribute is is a set of all possible values that we can enter in that column. For example, we have a column by the name registration number in our student relation. Now a set of all possible registration numbers is a domain for the registration number column. Similarly, we have a column by the name student name. So the set of all possible values or all possible student names is basically called the domain of student name column. It is defined here. Our domain definition usually consists of the following components: domain name, meaning, data type, size or length, and allowable values or allowable range if applicable. If applicable means you cannot find out all allowable values. Like in case of a student name, there can be millions of combinations for a student name. There can be millions of possible names, so you cannot figure out all possible values. However, you can figure out the maximum size of that column. Like the maximum possible length of a student name, let's say 70 characters, because we analyze the data and we figure out from our analysis that the maximum length of a student name was let's say 60 characters. So to be on the safe side, we add a cushion of 10 more characters and we set the limit to 70 characters. The other possibility is data type, uh, which means the type of data that can be entered in that column name. Like in student name, numbers is not possible, so data type will be only text or letters. Similarly, if we have a column for student age, the data type will be whole numbers, not floating point number, because age is not in floating point numbers. And here the size can be it will not be the size, it will be the range of possible values. So we know that age, we can say that the maximum age will be greater than or equal to 1 and less than or equal to, suppose, 110. So this is how we can limit the possible values for age column. So anyway, domain constraint means you apply a limit on each column, that what are the possible values that can be entered in that column. Sometimes the possible values are known. Let's say when a student applies for a program, now there are in each university there are well defined list of programs. So in that case, the program name column will have a specified defined domain means set of values. Let's say in case of FMS it will be BBA BBITM, MBA MBITM, MS in management sciences, and PhD in management sciences. So these 5 6 names is a possible set of names that can be entered in program name. So if a person who is entering data or editing data in a student column, in a student relation, and he enter any other value in the param name column except a set of these 6 or 7 values, the database will give an error and will not enter the data, and will tell the user that these are the possible values you have to choose from. So in this way we restrict the user from entering invalid data values in our columns. Okay. Integrity constraint. Constraint requires that each relation must have a primary key defined in it. So if we create a relation which has a set of attributes, but we don't define any attribute as a primary key, then it means that we have violated the constraint or entity integrity rule. It means that an attribute that has been made a primary key cannot contain a null value. A null value basically means non-existence of a value, or in other words, you keep the field empty. So whenever you make an attribute a primary key, 2 rules apply on it. The first rule is that a duplicate value cannot be entered in that field or in that attribute or in that column name, and second rule is we cannot leave that column value empty. So let's say when you are figuring out that which field should be made a primary key, you should analyze the data of that attribute, and you should check that if that attribute can be left empty, then that attribute does not qualify to be a primary key. Here in this example, if an employee does not registers for a course, like in this case, employee with ID 190 has not registered for any course, so his course title column, and obviously when he has not registered for any course, how can he complete it? So again, date completed column, these 2 columns are empty, or in other words, they have a null value in it. So these 2 columns cannot be primary key. So we are left with these 4 columns. So now we have to figure out that out of these 4 columns, which column should be made a primary key. So in short, what he is saying that when you are figuring out that which column should be made a primary key, you should check that whether the value of a column can be skipped at the time of entering data. If the value of that column can be skipped, it means that column or those columns whose values can be skipped does not qualify for primary key. So you should exclude those columns and then focus on the remaining columns and check which of those columns can uniquely identify each row in that relation, and at the same time they cannot be kept empty, or they can be left empty. So here is the definition of null value. A value that may be assigned to any attribute with no other value when no other value applies, or when the applicable value is unknown. And the entity integrity rule states that that no primary key attribute or component of a primary key attribute may be null. Here, the component of a primary key attribute means, let's say if you have a composite attribute, which means a primary key made up of more than 1 column names. So none of those columns can have a null value. Like in this case, in order line, our composite key is order ID and product ID. So while entering a record or any row in this order line relation, if we have the value of order ID but we don't have the value of product ID, it means we have to enter null in it. It is not possible. Anti-integrity rules does not allow this, because this is a part of or component of our primary key. So order ID, product ID, both combined become the composite key or the primary key, and their components are order ID and product ID. So they both cannot be null, or any one of those cannot be null. If order ID is null or product ID is null, or both order ID and product ID is null, the record cannot be entered in that relation, because it will violate the entity integrity rule. Okay, before going to referential integrity, in this table 4.1 he is given the domain values. So for attribute customer ID, domain name is customer IDs, description is set of all possible customer IDs, and let's say in this example the ID they have taken, or the format of customer ID is 5 characters, and all of them are characters. Like in our case, a registration number is alphanumeric. Suppose 1234 dash FMS slash, then the program name slash, then the semester prefix, which is S for spring and F for fall, and then the 2-digit year number. So in our case the registration number will be around 20 or 22 characters, and it will be alphanumeric because our registration number contains digits as well as letters. Now again, customer name, domain name will this is attribute name or the column name or the field name, and domain name will be customer names, and description is set of all possible customer name, like in our case set of all possible student names. Similarly, and the maximum size of this column is 25 characters. Similarly, for address, set of all possible customer addresses, the possible size of this column is 30 characters, and so on. Now see here, product standard price, it is the set of unit prices, set of all possible unit prices, and the prices are up to 6 digits, so monetary 6 digits. Similarly, product line ID, product line IDs, set of all possible product line IDs, and it is an integer with 3 digit so it's a 3-digit integer. It means the code assigned to each product line ID is a 3-digit number, and that's why their domain values are integers of 3 digits. And same is the case with the quantities. Now we come to referential integrity. Referential integrity rules state that the value in the foreign key field must match the primary key field, or it may or may not be null. And again, it means that in the foreign key column, whatever value we entered, that value must match its corresponding primary key values. In other words, let's say let's see this example. Now this customer ID is a foreign key. It means that, let's say we have 2 customers here with ID 1 and 2. So in the order table, when filling the record, the foreign key column customer ID can have either value 1 or 2 or null. I cannot have a value here which does not exist in this table except the null value. It's like if I enter a customer ID 3 here and the customer with ID 3 does not exist in the customer table, it means I am violating the referential integrity rule. In short, we cannot have a value in the foreign key that does not exist in the primary key. So this value must match with its primary key value in the related table. The only exception is the null value. If I don't have a matching value, I can put a null value here, or null value basically means I can leave this column empty. But again, I can only leave this column and empty if the relationship between customer and order is that each customer can have can place 0 or more orders. Then I can put a null value here. But if the relationship is that there's a mandatory condition that if I have a customer, the customer should must have at least one or more order. Again, if a customer should must have at least one or more order placed, so in that case I cannot put a null value here, because if I have a customer, the customer should must have a value in the foreign key column in the order table. So it means this customer ID cannot be null, because a null value means that an order has been placed, but it has been placed by no one. So actually this is not possible. Whenever there is an order, order would must be placed by a valid customer. So it means I should must have a valid customer ID in my customer ID foreign key in the order table. So this is what referential integrity constraint is. That referential integrity constraint does not allow you to enter an invalid value in the foreign key, which basically means that we cannot enter a value in the foreign key that does not match with its primary key. We will see this part in the next lecture, and